So finally what you do is you calculate an F statistic, and the F statistic is the mean squared between divided by the mean squared within. And when you do this, and you do a simulation over and over again, if you pretended that all the population means were equal to each other, and you randomly selected 3 samples and got their sample means and found the F statistic, and you did this over and over again, kind of like in the central limit theorem video, you would get a skewed distribution, and it's called an F distribution. And an F distribution is it's when you divide two chi-square distributions. So variance, it has a chi-square distribution, so we have variance on top and variance on bottom, and they both have a chi-square distribution, and when you divide them you get what's called an F distribution. You don't need to know that detail too much, but just letting you know. But you need to know that we're using an F statistic and it's skewed to the right. It starts at 0 because variance, which is what we're dealing with, we have variance, we have the mean squared between and the mean squared within. Those are both variances. Variances are always positive, right? We always square things, we take out the negative. So it's always going to be positive, so we start at 0. When the mean squared between is equal to the mean squared within, we have an F statistic of 1. And that means that our mean squared between is equal to what we would expect just by chance. So what I mean by that is, say in reality the population means are equal to each other, and we randomly select 3 sample means from those 3 populations with equal means. Right? When we're sampling, the sample means aren't going to be exactly what they are in the population because it's just a smaller sample. So just by chance you might get different sample means. It's probably going to happen. And so the mean squared within is an estimate of what we expect the variability in the sample means to be if it's just due to sampling error, if it's just due to chance. And in the real population, they're all equal to each other. So hopefully that makes a little bit of sense. So if we get a value of 1, it's just, that's what we expect when in reality the population means are equal to each other. Okay? If you get below that, it also means the same thing. It isn't until you get above 1 that there's more variability than what we expect. Okay? And when we have more variability than what we expect, that means we're more confident that the sample means do in fact vary from each other. They're significantly different from each other. So if you have greater than 1, then it's more likely that the population means are in fact different from each other. Okay, so we're looking for anything above 1, and the further away from 1, the more significant it is. And the more confident we are that the sample means are significantly different from each other, meaning that the population means are different from each other. And you have to get a p-value to say if they're significantly different from each other or not. But the higher the F statistic is, the lower your p-value is. So the higher it is, the lower the p-value. Okay? So let's go back to our example, and we had a really big MS between. This probably won't really happen in real life, but we're just for demonstration purposes. We have 2000 on top, and we had a MS within a 0.26. And if you put that in your calculator, so then you get a really big number of 7692. And I am so confident that this will be significant. I mean, if you ever get something in thousands, it's going to be significant. So it doesn't matter what our alpha level is, our p-value is going to be really small, and you can get the exact p-value in Excel. But for this example, I know it's significant. We don't need to go to Excel. So if you get a big F statistic, then that means that our 3 sample means are significantly different from each other, because this was really a lot bigger than 1. Okay? So if that's a little confusing, maybe try to read the handout again, and then try to maybe watch the video again. But that ends this video. As always, ask questions on the discussion board.